Hello, I'm Gemma Acton and welcome. It is a real pleasure to have you here with us today at the Building Better Futures for Health Challenge 2020, brought to you by IDE Group. Now, in a year when our borders have been closed and we really missed our international friends and cousins, it is such an honour to have people from around the world, both in terms of audiences and teams, here with us today. Now, before we dive into all of that and we watch the teams battle it out for the $25,000 grand prize, and that's in IDE services to help them kickstart their health journey, we do have a few items of housekeeping. Once we're through those, we will introduce you to the judges and the team. But first of all, it is my honour to welcome George Sidis, who is the Managing Director and co-founder of IDE Group. George, welcome.
Thank you very much, Gemma, and I would like to thank you all and welcome you all on behalf of everyone at IDE Group for tuning in to the 5th annual Building Better Futures for Health Challenge. I think this year, obviously with 2020, we're in a different format from what we've done in the past, but the principle behind what we're doing is the same, and sharing ideas and pitching them amongst the IDE Group community and choosing some of the better ones to work together to build a better future, for health systems and provide that to patients and clinicians around the world. This year we've had entries, as Gemma alluded to earlier, from all over the world, from 4 continents, and they've been really of very high quality, and we've been with the judges deliberating on those and deciding down to 3 very strong applicants that you're going to hear from later today, and using our key criteria of desirability, feasibility, viability to whittle those down. And I'm really looking forward to hearing from them, and I hope you guys are too. And thank Gemma very much for coming on today, and welcome her back to introduce the contestants and the judges.
Thank you so much, George. Well, we've heard from George how important the challenge is and the work that's gone into getting it ready. But who better to hear from about how much of an impact it can have on lives and careers than last year's winner? Now, that's Annie Mccauley. She has a product, Talkie Play, which is a digital-led technology solution to help children who are experiencing speech delays. Well, we managed to catch up with Annie and hear about what she's been up to since she won last year's prize. Let's take a listen.
Hi, I'm Dr. Annie Mccauley, the founder and CEO of Talkie Play. Our innovative technology makes ordinary objects like furniture and toys talk, sing, and play games to accelerate language learning for young children. We are the 2019 Building Better Futures for Health Award winners, and we were lucky enough to win the People's Choice Award as well. The grand prize, offered by IDE Group, allowed us to build our customised hardware for Talkie Play. Since then, we've experienced rapid growth in our preschool market. Our user base grew to 1,500 children in preschools in Victoria. Our independent trials have produced research-backed outcomes for language and social development. And we were all set to grow in Tasmania and New South Wales, but then the pandemic hit. While we did experience some growth hold, it's been a great opportunity for Talkie Play, as more children were staying home to practice language learning with their parents. We've now reached 11 countries for children with their remote home learning and language development. We really feel like we've been able to scale our access this year, and 2021 is looking bright.
Now, about today's challenge, it is really an innovation in itself. Now, created, as we know, by the team at IDE Group. IDE Group was founded back in 2003, and its goal was really to help organisations to create meaningful change, so give them that real start at life in the healthcare space. Now, it has a collection of diverse staff and collaborators and is an entrepreneurial partner helping discover, develop and deliver meaningful products and services with one goal. And this is such a wonderful goal, to build better futures for Australians and citizens around the globe. In 2016, co-founder George Sidis, who we just heard from, and Richard Sokolov, who we'll hear from a bit later on, they founded the Building Better Futures for Health Challenge to uncover ideas that can make a real difference to people's lives. And each year, as many of you would know, innovators, entrepreneurs and researchers are invited to enter to compete to win funding to bring their ideas to life and kickstart the journey towards commercialisation. So we've just heard from last year's winner, Annie Mccauley from Talkie Play, but let's see who's in contention this year. Time to meet the teams, one of the most exciting parts today. Now they're all watching from their green rooms. First up, we have Team Philia Labs from Melbourne, Australia. We have Team Aurora from Sydney University and Sydney Medical School, Australia. And Team Goal 3 coming to us all the way from the Netherlands. And now that we've met the teams, we're going to also introduce you to today's judges as they make their final preparations. First up, we have Anne O'Neill, the Director, Enterprise and International Partnership at the Office for Health and Medical Research. Welcome, Anne.
Thank you.
Next to her is Dr. Alan Taylor, the Executive Chairman of Clarity Pharmaceuticals. Hello, Alan.
Hi.
John Kelly, Chief Executive of Atomo Diagnostics.
Hello.
Welcome, John. And last but far from least, Mick Brooks, the Head of Radiology R&D Rydalmere for Radiology Business of Bayer.
Thanks, Gemma.
Now, I'm going to ask you a question before we hear the pitches. Let me start with you, Mick. What exactly are you looking for in today's winner?
Well, I think what we clearly want to see is something that will improve outcomes for both patients and clinicians. But it's important to me to see that we have some kind of sustainable business model as well. So a bit of both, a bit of innovation and a bit of actual business acumen is something that I'm looking for here today.
Makes a lot of sense. John, anything to add to that?
Yeah, I think products need to be solutions based. I think rather than just be a technology for the sake of technology, I think it needs to really address an unmet need, and I'll be looking to see how the pitches address that.
Alan, your thoughts?
Yeah, so typically there is a strong focus on the product and how they're going to get the product out there. But what I'm keen to see is a little bit of insight into the people behind it, because it's not all glitz and glamour starting these sorts of companies. And it's hard work and grit and determination that gets you through. It's the sleepless nights, the difficulty in raising capital and obviously growing businesses. So it'll be great to see some insight and some background on the people behind it and see how they're going to address those issues.
Absolutely. We always hear about the glamorous side of entrepreneur life, but there's certainly another big element to it. And let me ask you something slightly different. Now, how important is it for organisations and investors as well to keep supporting the Building Better Futures for Health Challenge?
It's really important, Gemma. I think for the inventors and the entrepreneurs themselves, they get a platform that's really unique to be able to present their early stage technology to a really wide audience. And in that audience are made up of lots of people, but most importantly, potential investors. And those investors can be public or private. And so I'm from government, and we run funds that actually invest in early stage commercialisation. This challenge actually opens the door for those inventors to get access to the users, the choosers, the potential payers, in a way that they probably couldn't do on their own, opening doors, making introductions and really getting some added value to the work that they're doing. And I think that value really, because of this challenge, is priceless.
Certainly, Anne. So everyone's heard what they need to do to impress the judges now. So without any further ado, let's meet the teams themselves. Now, our first team, as mentioned, is Philia Labs from Melbourne, Australia. And today's pitch is headed up by Dilpreet Buxi, PhD, and the Chief Executive and Co-founder of Philia Labs. And they focus on depression relapse management innovations. Welcome, Dilpreet.
Good afternoon. My name is Dilpreet. Thank you for having us here. I'm the co-founder and CEO of Philia Labs. Joining me in the Q&A is David Lester, our head of strategy. Before we begin, we just want to make a statement that the mental health challenges as a result of the coronavirus pandemic have only just begun. Now is the time to act. And we at Philia Labs believe that we can make a significant impact in overcoming this challenge. And on to our first challenge, depression management. When a person is being treated for depression using, let's say, antidepressants, there is actually a 1 in 3 chance of patients relapsing into a second depressive episode within 6 months. And relapse is almost it's a point where a one-off episode becomes a chronic illness. And therefore, it's critical. Oftentimes, sympathetic arousal, or the fight or flight activity in the body from stress, is a major cause of relapse in depression. And therefore, what clinicians would love to have is a way of monitoring that sympathetic arousal in real time. And let's take a look at why the existing tools are not appropriate for that monitoring. Firstly, you have questionnaires, which are the current standard of care. Patients will either accidentally or deliberately not reveal how they are truly feeling. Secondly, this is a snapshot instead of real-time changes. Then you have the consumer health wearables, which have come into the market in the last years. They claim to measure stress, but because of the lack of clinical rigor, they are unfit for purpose in healthcare. And so we at Philia Labs are developing a new correlate of estimating stress. We'll quantify a correlate of stress which is easy, objective, and has evidence behind it. And we filed a patent in August for this method. How does this method work? You have a fit-for-purpose wearable, which measures physiological data, such as heart rate and skin activity, which is in two parts: skin blood flow, or how pale the skin has become, and secondly, the presence of sweat in the skin. This data is converted by algorithms into a correlate of the body's stress response, which, according to the gold standard, it can be measured by a needle in the lab. In short, our algorithms mimic the measurement from the needle, but without the needle. How does this solution help depression management? It enables the provider to intervene in time. So the hardware-software platform consists of that wearable, the cloud server, in which data are converted by algorithms into risk factors for relapse, which are then reported initially to the clinician to intervene in time, whether it's changing of medication or observe in the hospital. Ultimately, the patient will use the reporting to manage his or her lifestyle better. The business model we propose is that of a device and data monitoring as part of a clinical monitoring program prescribed by the clinician. The patient is expected to pay about $1,000, which will save the patient tens of thousands of dollars in hospitalization. But we are investigating reimbursement. The market opportunity is in the hundreds of thousands of patients per annum in these three regions. These numbers must have gone up because of the coronavirus pandemic. Our IP strategy includes curating of data, filing patents, as well as trademarks, copyrights, and designs. We have a solid team of clinicians and people with business experience in both health and healthcare, as well as technical, wearable sensors, software, and data science. And we've also built up a solid partnership with academic collaborators who are leaders in their field of expertise, as well as commercialization partners. And amongst them was IDE, with whom we developed our product development strategy a few months ago. We then concluded that IDE's expertise is critical to us, at least in two areas. The first is developing that user interface to the clinician, which really should fit into their pathway of care and in their world. And second, it's to prototype our own wearable later on and define the commercial manufacturing pathway. And so we've worked pretty well with IDE. We look forward to working together. And with that, ladies and gentlemen, we thank you for listening to our pitch.
Well, Dilpreet, thank you so much for sharing that with us, and what a topical issue in a year when so many people's lives have been turned on their head. Love to hear what the judges have to say. Anne, let me start with you. Do you have any questions for Philia Labs?
Yes, I do. Thank you, Gemma. Thank you, Dilpreet. That was an excellent pitch. And I really agree with you that the next wave of this pandemic is going to be the mental health issues of the population. My question relates to the reliance of your technology on the clinician to be on top of the data that they get. We also expect the clinicians during this time will be quite overwhelmed. So do you think that there's also an opportunity for the patient to have a role in self-care?
Yeah. David, I'm going to let you go first, if that's okay.
Thanks, Anne. It's a great question. Yes, certainly the patients will have a role in managing their health. They have it now. The issue is there's really no way of the clinician following what the patient is doing and what the progress is, so that once you actually have the clinician diagnose the patient, they provide an intervention, and then basically that's it. The patient goes away. So having this device, it allows the clinician to remotely monitor the patient and see that there is a change going on, certainly in terms of his stress response. And then that allows them to engage in a much more efficient manner with the patient and identify earlier intervention. But it really is provides an opportunity of improving the patient-clinician relationship, because it's basically providing more timely and objective information, which is critical.
And
David, thank
to
you.
add to that, if I may, ultimately techniques like biofeedback can be used with this technology, which ultimately should empower the patient and give them hope, which matters just as much as correct interventions, towards their path to recovery.
Dilpreet, thank you. Let me turn back to the judges. John, do you have a question for the team?
Yes, certainly. Thank you. Firstly, very good presentation, really good concept. You mentioned the cost and reimbursement. Obviously, $1,000 could be a disincentive for someone to use this. Have you got any thoughts on sort of what that pathway to reimbursement looks like in key markets, and also how viable do you feel the product and the service is if reimbursement is unavailable and it remains a user pay model?
So I'll go ahead and just cut in and say that, so we're exploring reimbursement. I think each country, as you're aware, John, it's different, the challenge in each country. So there are some countries, for instance, where we think it would be a lot easier to gain, if we set $1,000, we've already got feedback and they say, yes, that's acceptable. So that our market strategy is evolving, but we do still expect to launch this in Australia. The one thing I would point out, though, is if you look at the direct and indirect cost, and if you look at the indirect cost on the patient, a patient that has severe depression and undergoes relapse, their cost is enormous. Their personal cost is enormous. And in talking with clinicians, they felt that something like this, even if it cost $1,000 for 6 months and it would provide a good outcome, patients would be willing to pay out of pocket for it. But on the other hand, I would say in Australia, there is potentially, we're looking into private insurers. They may be more open and I suspect they'll be a bit faster to react than the MBS. And in additionally, you've also got the NDS. So I think there are a lot of options, but the reality is these are desperate patients that are losing a lot of money, a lot of time. They're looking for solutions. So I think a number of them potentially would even pay out of pocket in a worst case scenario, but we really don't want that to happen.
Thank you.
Alan, what did the presentation leave you wondering?
Look, in the first instance, I thought it was a great presentation. I think the area of focus is a fantastic area to focus on. I echo previous thoughts on it, that it's a growing and significant problem that we need to deal with. My question will more revolve around the science, and this is obviously a diagnostic strategy. And in diagnostics, you have what are termed sensitivity and specificity, or false positives and false negatives. You're currently using 2 indirect measures, skin measures, as well as heart rate. My question is, when you delve into the data, how do you know what you're measuring in your analysis? And it becomes even probably more difficult in stress, where stress is a normal reaction. It's more the maladaptation to chronic stress, which is a problem. Because eustress is the good stress that you'd expect to have in running your day-to-day life, but distress becomes a real issue and can be a chronic issue and become obviously a subsequent health issue. So the question comes down to, with those 2 measures, how do you think the diagnostic will stack up, particularly from a sensitivity and specificity component? How are you going to go about determining that?
Yeah, that's a really good question. Thank you. So basically, we are using 2 gold standards, which are skin sympathetic nerve activity and muscle sympathetic nerve activity. And the reason for that is that in the lab, the science has said that when a person is anxious, the skin sympathetic nerve activity literally goes up, right? That explains why your skin goes pale, and hence the funny expression, you look like you've seen a ghost. So basically, to improve the sensitivity, we're taking the skin and the muscle sympathetic nerve activity as a gold standard to train our machine learning algorithms. The specificity in the field really will come from the clinical trials, right? Where we will learn, what analytics from our correlates of the sympathetic nerves activity truly matter in relapse outcomes. And along with that, we also know that in depression specifically, people's motor activity reduces. Their general sympathetic tone goes up, which indicates chronic stress. Their parasympathetic activity or rest and digest activity goes down. And ultimately, it is the changes that matter. Because in a patient who is heading towards relapse, his or her fight or flight activity either remains the same or it goes up. The rest and digest activity goes down, and the motor activity goes down as well. So that already gives us pretty good information as to what to detect to have that high specificity and sensitivity. I hope I answered your question there.
Sure, yep.
Let's hear one more question from the judges. Mick, over to you.
Yeah, thanks, guys. I thought it was a good presentation as well. I still have a question around your statements around the unfitness for purpose of the competition, which is essentially the nearly ubiquitous wearables that are already out there. So what is it that you guys have that is going to beat down the stuff that everybody's already wearing?
So in two parts, really. First of all, many of these devices are using heart rate and breathing rate, and they're using them as absolute measures, which are really proxies of the fight or flight activity. We, on the other hand, are using actual intraneural measurements of the fight or flight nerve to train our algorithms. So that's really a one step closer to the objective fight or flight activity in the body. And to the best of our knowledge, nobody else in the world is doing that. Whether it really improves clinical outcomes in the field, we will see, but that's a journey that you must take. And the other thing is that, the smart watches and smartphones that you have, they're consumer devices. So there's a lot of other activity going on, which means that there's a lot less precision in terms of the algorithms that you have. And simple things like the sample rate of the physiological data that you have, that may not be sufficient for making clinical decisions. As a rough example, you might have this really average heart rate that's taken over a few minutes during the day. What clinical evidence does that have? We don't know. And so the major difference there is the evidence and the approach that we'll take to build the evidence that the analytics really correlate with relapse outcomes. And that's, you won't have Fitbit and Garmin necessarily doing that from such a bottom-up approach that we are doing. That's my humble opinion. David, I don't know if you wanted to.
Yeah, I just wanted to add, someone referred to the team, and I think that's really what we've got as a pretty extraordinary team. And for instance, I personally have been involved in bringing health technologies to market for over 30 years. I've worked at the FDA for many, many years. I know the team understands what it is to develop a clinical device, and that's what we're developing. And that's in other words, the reliability, the dependency, the performance is going to be very, very different than what you see in any consumer device. Dilpreet's given you the science behind it. But the reality is that, again, and having been involved in clinical trials for many, many years, and having used some of those consumer devices, the clinicians never, ever know what to do with that data because they don't trust the data. So a lot of this is about, giving the clinicians the trust, which is going through the regulatory process, performing the necessary clinical trials, and abiding by all of those regulations. That is one of the major distinguishers, on top of the fact that we've got very, very powerful laboratory sciences backing up the whole concept that we're working with.
Now, Dilpreet and David, thank you so much for answering the judges' questions. We can't let you go just yet. We have some questions coming in from the viewers, and many thanks to everyone who submitted their questions. We're going to try and get around to a couple of them for each team, so apologies if we don't get through to yours. Maybe try again with one of the other teams. Let me start with this question. You mentioned the use of skin transparency for part of your analysis. How does skin colour affect your result, and could this limit the marker?
That's a really good question. So in general, dark skin tends to produce lower quality optical signals. How do I answer this without giving away too much IP? Look, ultimately, it's really the changes in the blood flow that matter. And that will be present in the skin regardless of how it is. Ultimately, as we get more data, I would strongly suspect that we would have to account for, the skin tone in terms of skin blood flow. Yeah, so I hope I answered that person's question.
Thank you so much, Dilpreet and David, for answering all those questions and for your presentation today, which was extremely illuminating. We are going to move on to the next team, so I'll ask you to step back and we'll check in with you again a bit later on. Now, our next team is Team Aurora. Now, that is represented by Edward Yang. He is a PhD candidate from Sydney University. Edward, welcome.
Thank you very much for having me. My name is Edward Yang. I'm from the University of Sydney. Dr. Pierre Kien will be joining us during the Q&A, and he's a cardiologist from the Westmead Hospital. And we're excited to show you guys the pitch of our Aurora system. About 17 million people die a year globally from cardiovascular diseases. We think up to a quarter are due to ventricular arrhythmias. The people at high risk are those who have scars within the heart, such as after a heart attack. VA is an abnormal heart rhythm disorder that arises from these scars. We implant cardiac defibrillators to terminate VA, but many patients still develop recurrent VA despite medication. Recurrent electric shock from the defibrillator reduces the quality of life and higher mortality. They feel like a kick from a horse when you're least expecting. Using catheters introduced into the heart, we can find scars and deliver ablative energy to cure VA. Often scars are deep in heart tissue, out of reach of conventional radiofrequency ablation that uses electric current to generate heat. Currently, catheter ablation is only 50% effective, but that's the best we have. Over 1 million people in the top 10 major cardiac device market are diagnosed with VA. The United States alone account for 500,000 VA cases. Right now, the state-of-the-art treatment for VA is radiofrequency catheter ablation, and this costs more than $3,000 for every catheter, which is single use. From 2003 to 2014, there has been an 8% increase in ablation procedures. Half of that 8% require deeper ablation than conventional treatment, which leads to an addressable market for our technology in the US alone to be greater than $120 million. In the top 10 major cardiac device market, there are more than 1 million diagnosed VA cases per year. This equates to a global market for an advanced catheter for VA to be greater than $300 million. So how do we provide a solution to this rising problem? We've designed and built the Aurora system to overcome the shortcomings of RF ablation catheters. Microwave energy can penetrate deeper into heart muscle than RF. It can also ablate through fat within and around the heart, where RF cannot. And it doesn't ablate critical arteries around the heart, whereas RF will injure them. We have tested the Aurora system on bench and in large animal models, and it produces promising results. We have a patent platform that encompasses the Aurora microwave antenna and the unique saline electrodes. The antenna is what we call an unbalanced antenna, which increases the volume of heated tissue while maintaining a flexible, low-profile tip that is soft and non-traumatic for clinical use. It has been problematic to place metal electrodes in the microwave field. The electrodes of the Aurora are formed from saline jets, which doesn't interact with the microwave field and also cause the catheter tip. These features allow the Aurora system to provide multiple sensing electrodes to identify scar tissue and deliver a large volume of ablation to address the scar in its entirety. We expect this will lead to better clinical outcomes for catheter ablation. Here we have the prototype Aurora catheter. As you can see, the tip is exceptionally soft, which allows the physician to manipulate it within the heart without the fear of damaging heart tissue. Although you may not be able to see, there are ports on the tip where the saline jets come out. These ports enable sensing electrodes within the microwave field. The saline flow also helps cool the microwave antenna, which many other microwave catheters have issue with. Here we have the handle which the physician will be holding during the procedure. On this handle, we can find the microwave input port as well as sensing electrode connections. This prototype works well in our testing, but there's a lot more to be desired. So we are situated in the cardiology workshop at Westmead Hospital. Our team have the expertise to design, test, iteratively optimize prototype catheters and validate their functionality on bench and in large animal models. The development of the Aurora prototype is undertaken at our world-class cardiac catheterization laboratory located on-site at Westmead Hospital. The development of a fully featured prototype Aurora system requires the exploration of designs, materials, and manufacturing options for several features. We have shown proof of concept of two core features of the Aurora system. First is the functionality of the saline electrodes to sense local tissue electrical activity within the microwave field at the catheter tip, and electrically stimulate the tissue from within the microwave field. The other is the capacity for deep lesion creation using the Aurora's antenna design, coupled with saline irrigation. What we don't have right now is multiple electrodes at the tip, catheter steering, a physician-friendly device handle, and ablation console, which can integrate sensory information obtained at the catheter tip to modulate ablation power to optimize efficacy and safety. BBFH funding will help us arrive at a minimum viable product incorporating all the desired features of a clinical grade system. We expect to spend a year on the initial build, iterative prototyping, ablation console assembly, and testing the system in phantom models. We are planning to spend 18 months testing and validating the Aurora catheter and ablation console in a large animal model. The research team is a partnership between the University of Sydney, Westmead Cardiology Department, Westmead Institute of Medical Research, and Westmead Applied Research Centre. The project is led by Dr. Kien. Dr. Kien and Dr. Barry have 6 patents relating to ablation technology and have raised over $2 million Australian dollars in grant funding. VA represents one of the most common causes of cardiovascular mortalities. The current standard of care for VA patients have greater than 50% VA recurrence and are frequently shocked by defibrillators. The Aurora system provides a solution to these patients, alleviate the burden for healthcare and government, and address an expanding clinical demand. BBFH funding will accelerate prototype development, increase its appeal to investors, attract partnership, create IP, and generate further funding opportunities for commercial development. Thank you so much for listening to our pitch. We're very excited to answer your questions during the Q&A.
Well, to Edward and to Team Aurora, thank you so much for sharing that with us and for giving us the sneak peek inside that lab, which is extraordinary to see. Now, it's just staggering to think that around 17 million people a year succumb to cardiovascular disease, and so inspiring to hear of work being done to try and work down that figure. Now, I'm sure the judges have lots of smart questions. Alan, let me start with you.
Sure. Firstly, once again, that was an outstanding presentation, and obviously the need is quite significant. Before my time at Clarity, I spent a lot of time in cardiovascular-based devices and working with companies who were commercialising them, everything from heart pumps to stents, as well as other interventional cardiology work. And what I knew from that sort of experience is that you need to raise a lot of money to get these products to market. I know you've got an outstanding team of clinicians and scientists, but when you're looking really to get this product to market, you're looking at investment probably north of $100 million to get there. And I noticed there was obviously $2 million of grant funding raised by a couple of your team. You need substantially more than that. Have you had any insights or thought about how you're going to go about that, particularly in the Australian environment, particularly because of the need, even before you sell a product, there's a big investment at stake. And have you thought about what that path will look like?
Yes, thank you for that, Alan. It is something that we're aware of. We're essentially making a Class 3 medical device. We've got another one as well that's more mature, that's in the pipeline. And the grant funding that we attracted will get us to a proof of principle preclinical prototype. And we're also creating the ablation console for this sort of platform microwave technology that we're creating. But to to get it into first-in-man trials, we need, as you indicated, significantly more. We thought that it would be between probably 5 to 10 million to be able to do a small pilot study, and then we would need further rounds of larger funding to upscale manufacturing to be able to bring the product to a market. So that amount of funding would need to be obtained through partnership, with a startup company as a vehicle. And so the question is, how do we attract that sort of commercial interest? What is the timing to spin out into a startup company to hold the IP? So those are various questions that we are having a lot of discussion with our commercial managers. We are validating some of our prototype catheters. And so we are aiming to address this in the next 6 months or so as our further experimental data come through. I think that you mentioned in the Australian market, I think that we are a smaller market, and it is very difficult to do any sort of manufacturing in this sort of context. Most of our work so far has been designing of prototypes and proof of principle work. We've sort of mapped out the resources. We aim to map out the resources that we need to pull together a preclinical version of the catheter, and that has traditionally required us to source a lot of components from various manufacturing facilities overseas. I'm hoping that by developing the roadmap, if you like, by refining technology, showing that it can work, by coming up with a preclinical prototype that we produce small quantities of proof of principle devices, that we can demonstrate to investors that at least we have a design and a roadmap and a robust intellectual property portfolio to be able to attract that size of funding.
Thank you so much for such a comprehensive answer. We do have quite a lot to get through this afternoon, so if possible to keep our answers just a little bit shorter, that'd be really helpful. Let me speak to John and ask what he would like to know from the team.
Yes, no, thank you for that. And I'd sort of echo Alan's point. My first ever medical device I worked on was a catheter for angioplasty, and the validation requirements are very extensive, and the company that developed that was a sizable multinational. So what are your thoughts on sort of the journey of the venture as a standalone entity versus a partnership with an established multinational, given the resources and capital and network needed to develop this type of technology? Have you guys given much thought to what that commercialization pathway looks like, and what types of partners are needed, and what milestones are needed to get those partners to the table? Because obviously I think that's hugely important for this type of product.
Yes, we have looked at that. There were a few different options, one of which was to investigate sort of licensing and so forth, or is that as a model, or perhaps partnership with another company to produce. If we're talking about large multinational like medtech companies, those companies we've done a number of, we've contacted, and some of them have shown interest, but at a level where the technology is already first in man. So they've sort of put it back to us that they would prefer us to be already fairly developed as a company before acquiring it. And examples of that in the medtech, examples of companies that have been acquired in that way recently, have been ablation systems, the mapping systems for cardiac arrhythmias that have been purchased for like $3 million plus. And so, I mean, it's a very different ball game, that end of the spectrum, to develop to that extent. And the regulatory pathway we have looked at, CE mark approval and TGA approval before FDA is probably the route we would go if we were to develop it ourselves. Now, if we're developing it ourselves, we need considerable capital. It would probably be a partnership between entities that are local, and whether they're venture capitalists or whether there are other companies that are, already making catheters locally in Australia. But we would need to get external funding that's significant in addition to that partnership, I would think.
Thank you.
And I can see you furiously scribbling away with some notes there. I'm going to have to ask you to put your pen down for a few seconds so you can ask Team Aurora your question.
Thank you. And I echo the comments that was an excellent presentation. And Edward, what an interesting PhD project you've undertaken. Congratulations on that. My question really is for Dr. Ken, this, if let's say everything goes according to plan and what have you, this is going to require a lot of training and education of the workforce that will need to use it. Have you given some thought to how that might happen and whether or not you've factored that into your commercialization plan?
So this is a catheter that is inserted into the heart using the standard techniques that we currently insert radiofrequency ablation catheters into the heart. So in terms of the user familiarity, we're aiming to produce a device that is essentially very similar in both feel and profile to what currently exists and is routinely used. In terms of the ablation console and generator, there will be differences between that and radiofrequency ablation. For instance, it may have different inputs, it may have different ways of modulating power, it may have different ablation protocols, but a lot of those things can be built into the console itself. And there will be a degree of, there'll be a need to provide some education, just like any new medical device that you ask clinicians to use. But being so the sort of clinician that uses this sort of technology on a a daily basis, basically, I don't envisage that this will be more complex or a big learning curve to go through. So thank you.
And for our final question from the judges, I'm going to turn to Mick.
Thanks. Yeah, very interesting technique that you have there. Hopefully it does prove to be superior to RF. I have a couple of quick questions. One is, I might have missed this, is your catheter intended to be single use? First off, you can probably answer that pretty quickly.
Yeah, in Australia, these sort of catheters with lumens or even diagnostic catheters are all in single use. So in this market, certainly. In the US, generally, currently ablation catheters, we're using RF and saline electrodes. Saline jets, irrigated RF catheters are all single use. So this is
okay. And using the saline jets as the as part of the electrodes, does that have any? Is there any impact on the local environment? For example, the blood viscosity, or is there any other factors that play into it that wouldn't normally be there in an RF field that might affect the microwave field that you're generating?
So the question is about whether the saline jets affect the microwave field in any way. Yes. Essentially, the saline jets. Saline is very similar to blood in terms of what it looks like from a microwave. So it doesn't really influence the microwave field in a way that's bad. It is needed, in fact. Even if we don't use them as electrodes, it's necessary to irrigate the tip of a microwave catheter, we have found. Otherwise, you get too much overheating at the tip. So this has been the problem in the past with microwave technology, is that it tends to overheat, and so you don't get big enough lesions. But one of the key features of this product is that you can get very deep lesions if you keep the catheter tip cool. And at the same time, these ports can be repurposed to sense electrograms.
Okay, thanks.
Now, we are getting some wonderful questions in from the audience, and I wish we had time to go through more of them, but I'm just going to have to keep it to one for now. So, Team Aurora, I'd like to ask you, how would the cost of the Aurora system compare with the current standard of care?
So there's a couple of parts to the answer to this question. One is that you can think about it as the direct cost of a product to the direct cost of another product, in which case the cost of ablation catheters are, the state-of-the-art ablation catheters are generally more than $3,500 or so US dollars. And, this sort of ballpark. Without having made a preclinical microwave ablation catheter, you can't really give a very accurate estimate to the cost of the final product. but the components that it uses are not special or rare in any way. And our estimates are that it would come in at approximately a similar cost to a standard ablation catheter. Now, if a patient fails an ablation procedure and has to have 3 more ablation procedures, then you have the cost of 3 extra ablation catheters plus cost of anesthesia, hospital stay, and so forth. And there's all these other human costs as well to that, so which are not easy to quantify. So if you had a product that changes the success rate of the procedure by 20%, by 30% even, that is a huge cost saving to the community.
Terrific. Team Aurora, thank you so much for both the presentation and for answering some of those really tough questions as well. Well, here in Australia, it's a really leisurely time in the afternoon, but over in Europe, it is very early in the morning in the middle of winter. So an extra big thank you to Goal 3, who is joining us all the way from the Netherlands. They're the third and final team in this challenge for today. And presenting on behalf of Goal 3 is Nick Versteed. He is the founder and chief executive of Goal 3.
Hello everyone, my name is Nick Versteed and I'm the CEO of Goal 3. At the Q&A, my co-founders Bart Bierling, Jelle Schuitenmaker and Rachel Loop will join me. Goal 3 is a social enterprise and we believe in fair and accessible healthcare for everyone, and that health workers are the key to achieve that. That's why our mission is to enable and empower health workers worldwide. And to explain you a bit where this comes from, it's actually I'd like to go back 5 years ago. 5 years ago, I was working in Tanzania as a tropical doctor. And during that time, I erected a neonatal intensive care department. And that was actually a really nice and good project. But what was most amazing, and the most amazing experience from that, was that there was one boy that was like one of the first to profit from this improved quality of care. And this boy survived prematurity and sepsis, and out of gratitude, his parents named him after me. They called him Nick Mandela, which I think is a really funny name in a way. So I call him Tanzanique. And this felt really rewarding, and it really made me feel why it is so important to do this work. But the full meaning of this didn't come to me until 2 years later. At 2017, I returned with my family to Tanzania, and I saw how my 1-year-old son Gus was playing with his 2-year-old boy Tanzanique. And at that moment, I really felt what it means to make an impact. And unfortunately, I also know what it's like when you can't make this impact, because I've seen dozens of children die from conditions which can be treated easily, which treatments cost less than €1, they were available, but we were not able to recognize these conditions in time. And this is a global problem, because every year, more than 6 million children die from conditions which are largely treatable and preventable. Effective and affordable treatments usually are available, actually. These children actually do reach healthcare, but because there's a shortage of staff and lack of adequate equipment, the quality of care is low and children die from a late diagnosis and late treatment. And that's a big shame, because we know that improved quality of care could prevent more than 50% of all pediatric deaths. So there's a large opportunity out there. That is why at Goal 3 we are developing the Impala monitoring system. This monitoring system is a user-friendly and algorithm-enhanced monitoring system which is specifically designed for low-resource settings. Through these algorithms, which we develop with our partners specifically for these settings, we enable and empower health workers to get a better diagnosis in an earlier stage and to make a better risk differentiation to who to attend to. And in essence, what we try to achieve with that is that we get the focus on the right patient at the right time to make maximum use of available resources. And we think through this approach that we can reduce the number of admissions by 20%, that we can reduce mortality by more than 20%, and that we can reduce admission time. And of course, these figures are immensely important in these overburdened health systems. And we are not doing this alone. We are developing this system together with the partners you see below in this slide. So it's some large academic institutes from Europe and Malawi to develop this system together. It doesn't stop at innovation in the technology space. We also need to innovate in the business model. That's why we want to provide this system through a monitoring as a service model, starting at $1 a day. By doing this, we make sure that it is available to everyone and accessible, but also sustainable. And we will start in Africa, in which, of course, we will focus mainly on Eastern Africa, because we want to first get a proof of business. So in the next 3 years, we want to develop our system and put the system ready in 10 hospitals. The average fee per system will be $365. In Africa alone, this is about 5,000 hospitals. So the total market for Africa is 36.5 million per year. In the second phase, we want to scale this up. In the 3 to 7 years after that, we want to grow to 5,000 systems, which is 200 hospitals. We want to grow to an average fee of $700 per system per year. And there's a total addressable market of 16,500 hospitals worldwide. At that stage, we will be supporting 250,000 patients per year, and we have an annual revenue of 3.5 million, and that was our expected break-even point. And our company will grow to a valuation of 15 million by 2027. And our real goal is to improve access to care for 100 million people by 2030, and that's our ambition. And to achieve that, we have assembled a great team of entrepreneurs, technicians, financial experts, and of course, medical experts. We are Goal 3. We believe in fair and accessible healthcare for everyone. Please join our mission, because we all health.
Well, Nick, thank you so much. It's really hard to argue with the goal of fair and accessible healthcare for all. Let me turn to the judges. John, how many babies have been named after you?
I don't know. Hopefully only 2. Listen, great pitch and a really good idea and a really good venture. I just wanted to ask a few very quick questions. In terms of the solution itself, is there hardware involved, or is it purely software? And also, what are the cost of goods of providing that relative to the services that you are going to charge for? And then the second part of that question is, we do a lot of work in Africa with our HIV products. Who's going to pay for it? Is it the African governments, or are you looking to have it funded through more global health tender programs?
There are 2 questions. Let me ask the first half of that and then pass it on to Jelle afterwards. So the first question is, what is involved, hardware or software? It's actually a combination of both. We think the main innovation will be in the software part and in the algorithms, but the hardware is a hard requirement before we can deliver that and make a difference with the software and the algorithms. So, and the cost of goods, we estimate that our monitoring system can then be sold, can be produced at the price of a range between 250 and 400 USD. So at a 5-year value of 1,800 USD, that provides sufficient margin. Jelle, maybe you continue on the business model aspect.
Yes, thanks for the question, John. I really like what you do with Atomo as well. So to answer that, I guess there are multiple streams of commercializing it. Of course, currently a lot of is done via tenders by a combination of the government with NGOs such as Save the Children Foundation or UNICEF or the World Bank. So these tender processes, we have to get really sharp aligned in these types of processes as well. But what we are also trying to do is build a business model that is maybe more sustainable on the longer term, which sells directly to hospitals. And that is why the $1 a day fee we are currently exploring. And to make this successful, we really need to have some sort of payment integration into our system to make sure that the hospital can keep paying up for such a fee. And of course, there's also like a third stream where systems would be purchased by foundations directly supporting hospitals. So as well in the Netherlands, it's probably also in Australia, a lot of foundations are supporting hospitals directly. So this could also be one of our customers.
Lovely, thank you.
Thanks, Jelle. Now, it's such a busy green room. I'm just going to quickly walk through who's in there with Nick, the founder. Jelle Schuitmacher, the marketing operations head, who we just heard from. Bart Beeling, founder and medical product designer. And Rachel Loop, who's a product developer. Let me turn to Mick. What would you like to ask goal 3?
Yeah, thanks, guys. It's a really laudable goal, I think, and I'm really impressed with the pitch. The personal aspects of it work well too. I have a lot of questions about the hardware again. Are you basing this on an existing design so that it has some aspects of reliability? And once you get these out in the field at that $1 a day, who is servicing them? Because we've been involved in a lot of programs across Asia Pacific, and the ongoing support and keeping things running is something that ends up costing you money, particularly if you're in remote locations in some of these areas. So is that part of the $1 a day model?
Well, once again, there's two questions there. Is it part of the $1 a day? It depends, probably, who is holding the hardware whatsoever. We say starting at $1 a day. So maybe in an initial phase, when our focus is mainly on the hardware, it would be $1, or mainly on the combination, it would be $1 a day, but at a later stage it would be $1 only for the software and the algorithms behind it. Bart, maybe you can reflect on the hardware aspects and the system and the servicing.
So thank you for this question. For the hardware, we are developing or using both existing components. So for example, we don't see any, we don't want to make an effort to develop the next ECG or SpO2 sensor, for example. But for other aspects, so we are developing or going to test a new sensor, which I've been part of over the last few years, which is lithography sensor, we call it. It's a very thin foil, which is a very reusable sensor, which is really critical in these settings. So you sit on top of it or you lie down on top of it to measure the heart rate and the respiration rate and the movements of the patient. And for the maintenance and the repairability of the system, we are actually in touch with some of the hospital technicians in Africa and are exploring options to create the system in such a way that as much maintenance as possible can be done locally with the engineers which are there. Because what I've been seeing in Malawi, for example, where we've been testing, is that there are engineers, but often they are not given the tools or the replaceable parts to actually repair the system. And we want to make an effort to create an environment in which it is possible and collaborate with these people to make a more sustainable solution.
Thanks.
Thank you. Let me pass the floor to Anne.
Thank you. Such a compelling narrative in the lead up to your journey, so thank you for sharing that. The question that I have is really about data security and its integrity and how you plan to manage that in terms of storage and in terms of really ensuring that the data that you're collecting is in safe hands.
Yeah. That's an excellent question and very important from an ethical and a regulatory standpoint. What we're looking now is we are working together with a Dutch company that is developing distributed data storage systems. So that means that the data will be stored local or on a cloud, but either way the key for accessing this data will be at the local storage. And by integrating that in our software backend, we can request for data if we need it for evaluation of our product or for improvement of product or developing new products. But the key will be lying with the end users and the ones who have generated the data.
Thank you.
Alan, final thoughts?
So once again, I echo the previous judge's views. It's an outstanding sort of process and contribution you're trying to make. I must probably discuss my limitations here. I don't have a lot of experience in social enterprises, and a lot of the things I've focused on is bringing new technologies like devices and pharma products to market. Not so much technologies that look to really redistribute resources. So my question will be more fundamentally around, you provided some what were rather definitive numbers of 20% changes in resource allocations and the like. My question is, given you have so many things that are going to be introduced to a new environment, such as the technology, the hardware, and then the software itself, and you have to integrate into a cultural environment, a different system, one that you might be used to, but not necessarily that's highly technological. How did you get to those numbers? So how do you know what you know about providing that resource distribution and the like, and how are you going to go about achieving it?
Yeah, so two excellent questions. So one is really about what can we achieve and how do we substantiate it and how do we make sure that our intervention can be implemented. So regarding the first question, there we have some outstanding research from the Netherlands which demonstrated that applying these algorithms through in this technology could save up to 6 hours in getting an earlier diagnosis, even in Western settings. So for every hour that you delay in diagnosing sepsis, mortality goes up by 10%. So potentially in a Western setting, you could save up to 60%. At an African setting, the diagnosis comes a lot later due to the restrictions regarding staffing and equipment. So saving time there is easier compared to a Western setting. So, and then substantiating that more from practice, I know, and this is something we, of course, the numbers have come up with our research partners, is that, there's quite a large group that you admit while it's not needed, and there's quite a large group that you keep because you don't know if somebody can go home. So by just saying, okay, just if you can differentiate the 20% who are best from the 80% who are worst, then you can easily not admit them or discharge them home. So that's kind of reason numbering. Regarding the implementation, what we follow is a real frugal innovation approach. Not increasing complexity, but by reducing complexity. And I like to compare it to Google Maps or whatsoever. Everybody around the world is now using Google Maps. And there's a world of complex algorithms behind that. There's a lot of software. There's very much complexity, but everybody can use it, even my grandmother. So that is our approach in making sure that we implement it, making things complex things, make it simple and make it accessible.
Monique, thank you. Before I let you and the team go, I've got lots of questions again from our audience, so thank you to everyone for sending them in. The one I'm going to go with is this one. How does Goal 3 aim to help healthcare professionals deal with a sudden increase in patient admission, particularly in low resource areas?
Well, that's an excellent question, and I think in any setting this is a challenge, of course, because it leads to overburdening of a health system. But if a health system is already overburdened, it becomes a lot more important to prioritize who to admit, who not to admit. And as I just stated, this means that you need to make a very good risk assessment. And our tool would be suitable for making that risk assessment by combining vital signs like heart rate, breathing rate, and movement and temperature in a combination with demographic factors like age, sex, and clinical data. We can make a better prediction about who should be admitted and who not, and also how to put focus on the right patient at the right time.
Well, Nick, and to all of Goal 3 in the Netherlands, thank you so much for getting up early and helping with the presentation and the questions. Well, that brings us to the end of the pictures, and it's time for me now to boot out the judges. We will, of course, be welcoming all of you back, but not until you have deliberated and decided upon who is going to take home the $25,000 grand prize. That is $25,000 in IDE services. Thank you for your questions and good luck on what is sure to be a difficult decision. And of course, it's not just the judges who get to decide who they like. We do, of course, have the Viewer's Choice Award, which we'd love you all to vote upon now as well. I'm just going to run through these instructions again to make sure you all have a chance to participate. So up on your screen, there is a QR code. You can simply scan that and cast your vote that way, or you can log on to slido.com and use the event code on your screen to access the voting. Now that's a $5,000 in IDE Services prize for the winner of the Viewer's Choice Award. So really worth putting your vote forward for any one of those three very worthwhile competitors. And while we wait for the judges, I'm going to do a quick recap of what we heard from the three teams in case you're still struggling to decide which one gets your vote. First off, we saw Philia Labs all the way from Melbourne, Australia. They presented their solution, which is a fit-for-purpose device and platform to monitor and prevent relapse of depression. Then we went to Sydney, where we heard from Team Aurora, who presented the Aurora Catheter. That is an innovation that aims to improve the quality of life for patients with heart disease. And then just now we've heard from our friends in the Netherlands, Goal 3, which presented the Impala solution that aims to support low-resourced and staffed environments to monitor the vital signs of hospitalised children, preventing unnecessary deaths. Now, while you're voting, I want again to thank everyone for all of the preparation they put into the application process, the videos, and all, of course, the ongoing background work they're doing on these incredible initiatives that really do aim to revolutionise healthcare as we know it. And it's just such an incredible overall challenge to be a part of, and we're so lucky to be able to see today what everyone has come up with. Now, while our judges are no doubt deep in deliberation, let's have a quick look at a video that comes from the founders of Building Better Futures for Health at IDE that shows us more about the company behind this.
Founded in 2003 on a powerful partnership between two school friends, IDE Group is a company that loves to work closely with their partners to develop medical products and services that bring about meaningful change and build better futures. To date, they have started or grown over 80 medical technology businesses and worked on over 400 medical projects.
We met a long time ago. It was when we were both 12 years old at school, just in class, and we've pretty much been inseparable since. Went through university together, even when we were working in different, in our first jobs in corporates, we still spent a lot of time together outside that. And through that process, we sort of realised that we each were wanting to do something different.
When we first realised that we could bring value to the medical technology industry was a little bit along the journey, because at the beginning, the vision was to create an end-to-end product development group. That was our original vision. But what we saw was an opportunity for a firm that could do very early stage work, so pre that design work, to identifying new opportunities and taking that all the way through design and detailed design and engineering and new product implementation and even manufacture. Within the first 2 or 3 years of us starting, we worked out that the way we worked, how we worked, and our values and the rigor that we applied in terms of opportunity discovery, design, engineering, and bringing that through to manufacture worked really well and played very well to the medical technology industry.
So IDE is an environment where people are really encouraged to challenge the status quo, where no idea is a bad idea, and people bring a really diverse set of skills. People feel comfortable speaking their minds, and they really strive to find new and better ways of doing things, and that makes it a really lively, challenging and fun environment. So we've entered into a partnership with the CSIRO to create a new treatment for age-related macular degeneration. We're developing a complete drug delivery solution that's going to significantly reduce the frequency that patients have to have these injections in their eye. We work together to develop products that make a difference in people's lives, and I find that really satisfying.
So I think in terms of what we look for in potential partners, someone that we can work through hard times with.
We're really proud of what we've achieved, helping building businesses for others and building our business. And I think we want to sort of double down on that and grow into that space and help more people build their ventures.
So I see a future of IDE where we continue to develop the long-term partnerships with new partners, working together to create new IP and to build new businesses around that IP. I see a future where we do more investing and in-licensing of our own technologies. And I believe that is more and more what IDE as a group will do going forward into the future.
IDE, working together to build better futures for health.
Well, another inspiring story to add to all the ones we heard this afternoon. And given that we are almost ready to announce the major prize, we're going to ask Richard Sokolov, the co-founder and director of IDE Group, who you just heard from then, to help us announce these winners. Richard, welcome.
Thank you for having me.
What did you think of those brilliant pictures?
Yeah, it's quite amazing actually, just the diversity, the uniqueness, and the quality. I mean, the diversity of the problems that they're trying to solve, you know, the uniqueness of all the solutions. I mean, it's amazing. And the quality of the people behind it. I mean, we had such a short time to put this whole thing together under, you know, obviously these COVID issues that we're all dealing with, and to see this come out today was really amazing. So I really enjoyed it, and it was great. Yeah.
Now, I see the judges are filtering back in, but of course, before we get to the judges' decision, we do have the results of the Viewer's Choice Award, and so we will soon find out who is the crowd favourite that's going to take home that $5,000 in IDE Group services. Richard, would you like to do us the honour of announcing who the winner of the Viewer's Choice Award is?
Yeah, first I'd like to thank everyone online who's voting and who participated and watched this presentation today, and hopefully we can do it again in person next year in the different circumstances. But the viewer's choice for 2020 is Team Philia Labs. So congratulations, Dilpreet and the team.
Well, many congratulations to the Philia Labs team, and to indeed all teams, but most particularly Philia Labs, for having the idea that really resonated with the audiences who had tuned in online to this. I'm sorry, given this is virtual, that you can't hear everybody clapping, but I'm sure there's lots of claps going out at audiences all around the world. Now, the big moment. We do have the judges back. And of course, as a reminder, this is for the $25,000 in IDE Group services, the grand prize. And Richard, we'd like once again to ask you to do the honours and announce the winner.
Yeah, thanks, Jim. I think I had the easy job here, just to read this out. You guys had a tough job, so thank you very much for judging. And the grand prize for Building Better Futures for Health 2020 goes to Aurora. Congratulations.
Thank you so much, Richard. Many congratulations to Team Aurora for your work on the Aurora catheter. I'm sure we'll hear much more from you in the future. But before we go, we wrap up for today, let me just turn to the judges, who I'm sure you're glad that decision's behind you, Anne.
Very much so.
Would you like to give us some insight into why the judges decided Team Aurora?
Absolutely. This was a really, really tough decision. You can't see virtually the scratches and bruises we've given each other making this decision. The very compelling cases made by all of the pitches, we really enjoyed them. This was a very, very tough year. The team for us is a great team. It has great technology, very needed technology, and we think that they will absolutely benefit from the support and the input from IDE Group to not only work up their technology, but also to help them with their commercial and commercialisation strategy, which is really critical for a technology like this. So congratulations, Team Aurora. Thank you so much.
Team Aurora, let me just ask you, what does it feel like to be crowned the winners of the Building Better Futures for Healthcare Challenge for 2020?
I'm just too excited that my brain is still trying to process what is going on. but thank you so much for this event.
And how will you celebrate?
We already have our team together. We're already trying to open some bottles, I guess.
Probably have a cup of tea in the workshop. It's been a fantastic process, and thank you all the judges for having us. Edward has put in a lot of work, so congratulations, Edward. I think it's a great effort, and I'd like to thank the other members of our team and our collaborators.
Well, you've obviously been working incredibly hard, so definitely time for a little play this afternoon, a celebration of everything that you've achieved. Well, that does wrap up the BBFH Challenge for 2020. Now, a huge thank you to all three incredible teams and also to our panel of judges. Just a reminder of who we had here. Mick Brooks, the head of Radiology R&D at Rydalmere for the Radiology Business of Bayer. Dr. Alan Taylor, Executive Chairman of Clarity Pharmaceuticals, John Kelly, Chief Executive of Atomo Diagnostics, and Anne O'Neill, Director, Enterprise and International Partnership for the Office for Health and Medical Research. Now, Richard, George, and the whole team at IDE Group, congratulations on finding yet another incredible innovation. We're looking forward in a year's time to an update from Team Aurora, just like we had the update from Annie Mccauley earlier today. And there is no doubt that all of these teams are working to improve the healthcare of Australians and citizens around the world. Thank you so much to the audience for joining today, for your votes, for your questions. We really couldn't have done it without you either. We look forward to seeing you in 2021.